In today's video, I coded Minecraft from scratch using Godot and C++. Walking around the world, you can see the infinite chunks loading in, each with their own procedurally generating terrain. Now you may be wondering how we got here, and it all starts at the beginning. The first thing we need to do is render a block. All we need to do is have a mesh instance 3D, static body 3D, and a collision shape 3D, and then we have our first cube. However, one cube on its own isn't useful. But by using Projekt Jenova, we can write a C++ script for a chunk that spawns in a 32 by 32 by 32 grid of blocks. Each cube is spawned from a packed scene that is passed into the chunk. Then once we have this chunk, I added code for a character controller as I take the base Godot character controller movement and then translate it to C++. Once we've done that, we can walk around our chunk using our character. Now once I have one chunk working, I manually add in a second chunk. But these chunks are really boring, as they're all made up of the same kind of block. So to fix that, I have the code generate multiple standard materials. I give each material a different color, and then I pass them into the blocks. I also add a build chunk function that adds different blocks to a 3D array, which is used to determine which material to use. And with it working, it looks like this. However, even though we had multiple blocks now, they were all still solid colors, which I fixed next. I fixed that by modifying the materials and passing in a texture instead of a color. I also add two new blocks, which are sand and stone. So with textures working, I add a bunch more chunks in now. However, it causes a few problems. For the first one, it's very laggy, and the second one, we actually reach the element limit in Godot, and not all the chunks fully render in. So a quick fix to this is by adding this code in that only renders blocks that aren't fully surrounded by other blocks. As if a block's fully surrounded, we do not need to render it, as there's no way you'll be able to see it. However, we can take this a step further. Instead of creating a mesh for each cube, we can create one multi-mesh for the entire chunk. So this code here iterates through the entire chunk, and for each block that should be visible, it adds it to the multi-mesh. And it looks like this here, which is much smoother and less laggy. However, you may have noticed that when we did this, all the textures became the same. So I tried to fix this, and the first time, it didn't go so well. And the way I fix this is by going into the multi-mesh, and in the code turning on instance data, and specifically custom instancing data, and I'm able to pass in a color that represents the block ID. And then I use this block ID to sample from a texture atlas, and we get this. However, this still looks really bad, and that's because each block, if we do it the way that we were doing before, where we spawn in a full cube, references a different part of the texture atlas for each part of the cube. So that's why as they go out of bounds, you get all these purple and black colors. And the way we have to fix this is by changing from rendering a full cube and instead doing 6 separate faces. So this part of the code here breaks that down, and it is the C++ side, which instead of checking whether a full block is covered, we check which individual faces are exposed, and we send the faces to the multi-mesh instead. And then in our shader, we take that instance data and we check which way the face should be facing. And if we render one of the faces, it looks like this. And if we apply this face method to all 6 sides, it looks like this, and it's back to being normal. Except this time it's much more efficient, as we have one mesh per chunk instead of one mesh per cube. You may notice, however, that there's this purple fog that appeared once we made this change. And that's because with this new method, we have to use a texture atlas. And because we're using a texture atlas, as we zoom out, the map compresses the textures, and we actually get bleed in from the other textures. And then the blank spaces, which are purple and black, also bleed into this, creating this purple fog. So the way we fix this is by turning our texture atlas into a texture 2D array, and then changing our shader to adjust that accordingly. And once we do that, the purple fog goes away. So the next thing I fix is adding collisions back in, as once we did the multi-mesh stuff, the collisions went away since we weren't using the pack scene anymore. So the way I get the collisions back is at the end of our generate mesh function, I call this generate collisions, which I add, and in there I loop through each block, and if each block is not completely covered, then I create a collision shape and a static body and add them to the scene. And once that's working, we can run around the scene again. And once I get collisions working, the first thing I do is instantly disable them. And that's because there's one last optimization I need to make to multi-mesh. The last optimization for multi-mesh is allowing one chunk to look at another chunk and not render faces that are covered by the under chunk. So the way we do this is we first move the packed byte array that stored all of our blocks into metadata, and then we allow our world to pass a callable function to all the chunks that allow chunks to reference the world to reference another chunk. And once we do that, in our generate mesh code, we use that callable function to grab each of the 6 neighboring chunks for any chunk. And then in our emit faces, we can check one of those neighboring chunks. And if there's a block where the face is, we don't need to render it. And then I actually optimize the collision generation, similar to what we did for multi-mesh. I instead create one collision shape for the entire chunk using a concave shape. And we generate all the faces based on which faces are showing. And once that's all working, the next thing I add is infinite chunks. So this is where if you run in a direction, chunks will keep generating in front of you and chunks behind you start to delete themselves. So the way that I do this is I modify the original code from onReady to generate chunks, and I add a part where it will delete chunks behind you. And then I call this whenever the player moves from one chunk to another. And I queue the last generation of the mesh as that's the most taxing and split it off across multiple frames so it's not as laggy. And once all that's working, I borrow some Perlin noise code and I get this infinitely generating procedural terrain that you can see here. And now that I have Perlin noise, I go and modify all the values. I add in water and I also add in snow, although you don't see it in this scene. And I make the terrain look more varied. I also add in trees that will generate based on the noise. And then finally, the last thing I do is I add block placing and breaking. So as you can see here, I can place a bunch of oak planks. Now I hope you enjoyed that video. And if you want to see more, you should click on the video on the left if you want to see another Minecraft video, but this time where I make it in just C++ with no game engine. Or click on the video on the right if you want to see more Godot content and specifically callable functions. And until next time, see ya.